Hi, my name is Michael Benben, and I am in Challenge 2016 in Calculus 2000. And last week we found the area of an ellipse, but this week we're going to be finding the volume of a torus. So in order to do this, we're going to be using the washer method, and we're going to have to rotate a circle around the y-axis. So we're going to be having to solve the equation for a circle for x instead of y. So when we do that, we get x is equal to radical r squared minus y squared. And then in order to be able to use the washer method, we're gonna need the equations for the inner and outer radius. So by using the equation for a circle, we can find this by seeing that the inner radius is equal to the outer radius minus the area of the circle set equal to x, and then the outer radius is equal to the outer radius plus that equation as well. So now we're going to plug this into the washer method equation, so then we can be able to find the volume of a torus. So now we have the integral here for using the washer method to find the volume of a torus. So we're going to begin with pi times the integral from negative r to r of the outer radius minus the inner radius. So and we're going to square each one, of course, because that's part of the equation. So our first step is going to be to distribute everything and be able to cancel out some of the values here. So we can cancel out r squared, x squared, and outer radius squared. So then we end up with pi times the integral from negative r to r of 4r. Sorry, it should be 4 pi r. Times 4 pi r times the radical of r squared minus y squared dy. And then we can take out the 4 pi r because those are constants, so we can just integrate this equation. Okay, so now in order to integrate this, we can see that when we break it down, we can do trig substitution. So in this case, we are going to be substituting with sine theta. So we see that y over r is equal to sine theta, so we'll be plugging that into the radical here. And then when we solve for y and derive it, we can plug in r cosine theta d theta for dy. So then we continue integrating this through through trig substitution, and then eventually use u substitution if needed. Okay, so now as we continue to integrate this, we can shorten everything. So 1 minus sine squared theta is equal to cosine squared theta. And the r from here is a constant, so that could also move in front of the integral. So now we're going to have 4 pi r, our outer radius r, times inner radius r squared, times the integral from negative r to r, a radical cosine squared, which will become cosine, times cosine. So when we do that, we end up with the integral having cosine squared, and using our trig identities, we know that cosine squared is equal to 1 minus cosine 2 theta over 2. The 1/2 is another constant, so we take that out to the front, and the 4 becomes a 2 in front of the integral. And then we can finally integrate this and get 2 pi outer radius r times inner radius r squared of theta plus 1 over 2 sine 2 theta from negative r to r. So now we can plug in our limits and be able to get the answer. But actually, before we do that, we need to put what theta and sine 2 theta are back into the equation. Okay, now we can be able to replace these thetas for variables that can include the negative r and r, so that we can be able to solve for the volume equation. So we know, first of all, we cannot replace sine 2 theta right away, but we can break it up to 2 sine theta times cosine theta. When we do that, the 1/2 and 2 and right there cancel out, so we end up having the integral being included for theta plus sine theta times cosine theta. So theta, we know, is the inverse sine of y over r plus sine theta, which is y over r, and by using our information we can create this triangle with the different variables of the original equation, and we can see that cosine is equal to radical r squared minus y squared over r. So now that we have all these variables replaced with the variable y, which we can plug the r and negative r into, we can now solve for the equation. Okay, so now we have this equation, and we're going to be plugging in negative r and r. So this kind of went off the whiteboard here, but we have the inverse sine of r over r, which is just 1, plus r over r again, which is 1, times r squared minus r squared, which is 0. So in this area, we're going to end up having the inverse sine of 1. And then now we're going to look at the other side, and we're going to see that we're going to once again have the inverse sine of negative r over r this time, so it's going to be of negative 1, plus negative r over r, which is negative 1, times the square root of r squared minus negative r squared. Now the square root of negative r squared is just r again, so that's going to be 0, canceling this out, so we're just going to be subtracting the inverse sine of negative 1. So now we're going to finish off by solving this and reducing it down to get the final equation for the volume of a torus. Okay, now that we've plugged in the r's in, we can see that we have this equation. So we're going to end up with 2 pi outer radius r times inner radius r squared times pi over 2 minus a negative pi over 2, because the arc sine of 1 is pi over 2 and the arc sine of negative 1 is negative pi over 2. So solving this out, we end up getting the final equation for the volume of a torus, which is 2 pi r times pi r squared. And that will be it for this video, and see you next time.